Our surroundings, the sky, trees, people, and our image in the mirror are made visible to us by reflection, where light bounces off the surface of the object, and this light reaches our vision. Most of these objects do not emit light, but we can see them because light is reflected off of these objects. Let's consider a ray of light hitting the surface, which is called the incident ray. The incident ray comes at an angle, which is called the angle of incidence. The ray of light that bounces off the surface is called the reflected ray, and the angle at which the reflected ray bounces off the surface is called the angle of reflection. According to the law of reflection, the angle of incidence is equal to the angle of reflection. Here we see an illustration of the law of reflection, where the vertical dashed line is normal perpendicular to the surface. The angles of incidence and reflection are measured relative to the dashed line. We can therefore say that the law of reflection states that the angle of incidence, theta I, is equal to the angle of reflection, theta R. Reflection occurs on both smooth and uneven surfaces. If multiple incident rays parallel to each other reach a smooth surface, such as still water, the reflected rays are all bounced off at the same angle. This results in a clear image known as specular reflection on the surface. Some examples of objects that give off specular reflections are plane mirrors, smooth glass windows, and clear still water. When reflection occurs on uneven surfaces, the law of reflection is still observed, with multiple incident rays bouncing off at multiple reflected rays due to the texture of the surface. Light is diffused, and a diffuse reflection occurs. Some examples of objects that give off diffuse reflections are textured glass and a rough asphalt road. A plane mirror is a smooth surface that produces a specular reflection. It is very smooth, so when light hits the surface, the resulting image is not distorted. How does the law of reflection cause us to see an image of ourselves when we look into a mirror? Consider the image on screen and imagine yourself standing in front of a plane mirror. This image shows how an image is produced from light being reflected off of the plane mirror. Light hits the object at different areas, and this is reflected on the surface of the mirror, the solid red lines. The green dashed line is normal to the surface of the mirror. This shows that the angle of incidence is equal to the angle of reflection. If we trace the red solid lines towards the back of the mirror's surface, the dashed lines, the image that we see appears to be coming from behind the mirror. This image appears to have the same height as the object, and the distance of the object is equal to the distance of the image, and this is how our eyes perceive the image. Reflection is when light bounces off the surface of an object, and all reflected light obeys the law of reflection. The ray of light hitting the surface is called the incident ray. Where the incident ray comes in at an angle is called the angle of incidence. The ray of light that bounces off the surface is called the reflected ray, and the angle at which the reflected ray bounces off the surface is called the angle of reflection. The law of reflection states that the angle of incidence is equal to the angle of reflection, and this law is observed on both smooth surfaces producing specular reflections where reflected rays are all bounced off at the same angle, and diffuse reflections, incident rays bouncing off at multiple reflected rays. The image we see when we look into a plane mirror has the same height as the real object and has the same distance as the real object from the mirror.